state equation of a second order system. We consider the system given here by the block diagram. I have two integrators, so I have two states, x1 and x2. So there is no memory in the sum, in the amplifiers, and so on. We have one input and one output. We have to give first the state equation in a matrix form. So this is my system. I have one input u, one output y, one integrator and another integrator. So to find the state equation, I have to express the derivative of the state variable, which are inside the integrator, inside the memory, and x dot 2. So I have to express x dot 1 and x dot 2 as a function of the state variable, so x1, x2, and the input u. I have also to express y with respect to x1 and x2. If I do this, I can also add u. If I am able to do this, then I will have a modelization of the system under the form of state equation. So let us start with x dot 1, then x dot 2, and then y. So for x dot 1, which is here, it is the sum of several things. First, it is the sum of minus x2, so minus x2 due to the minus here, plus u here, minus 3 here, x1, and plus y, but y is not allowed, and y is 2x1 plus x2. So 2x1 plus x2. So note that I have a simplification here with the x2, and I get that it is equal to u minus x1. Okay, for x dot 2, it is the sum of several things. I will have x2, and also I have x1 here. So there is no simplification. And what about y? Y is the sum of 2x1 plus x2. So this corresponds to the evolution equation, and this is the observation equation. I can put this in a matrix form, and I get that x dot corresponding to x1 dot, x2 dot is equal to, so I will have minus 1, 0 due to this x1, x2, so it's a vector x, and here I will have 1 and 1 plus 1, 0 u due to this, and here I have no u, and y equal to 2, 1, x. So this is the state equation in a matrix form. Second question, I have to calculate the characteristic polynomial of the system and to conclude if the system is stable or not. So for this, I look at the matrix A, so second question, and the characteristic polynomial is defined by P of S equal to the determinant of S I minus A. So it is equal to 1 1 time s minus 1 minus 1 0 1 and 1, and I take the determinant of this. So which is equal to the determinant of s plus 1. Here I will have s minus 1. Here I will have 0 here and minus 1 here. This is equal to s plus 1 times s minus 1. This is a characteristic polynomial. We observe here that the eigenvalues, so the spectrum of A, or if you prefer, the eigenvalue, is a set defined by the roots of this polynomial. So it will be minus 1 and 1. So it means that I will have, in the response of the system, I will have some exponential minus t and exponential plus t. Due to this, the system is not stable. This is due to the fact that I have one of the root, or one of the pole, or one of the eigenvalue of A, or our equivalent, which is on the right plane of the complex plane, of the right half plane of the complex plane. As a consequence, I conclude that the system is unstable. Question number 3. Calculate the transfer function of the system. So for this, I will come back here. I will take this equation, so question number 3. I will take this equation and I will go to the, from this to the Laplace plane. So the derivative here of this equation become, derivative of x1 is x hat 1 equal u hat minus x hat 1 to this, s x hat 2 equal to x hat 1 plus x hat 2 due to this, and the last one is y hat is equal to 2x1 hat plus x2 hat. So as a consequence, I can isolate here. Recall that to have the transfer function, I have to express y hat with respect to u hat. So the first is quite easy here because x2 is not involved in the first equation. So I can quickly isolate x1. So x hat 1 is equal to u hat divided by s plus 1. X hat 2, I can isolate it, and I will get here is equal to x hat 1 divided by s minus 1. So s here and minus 1 due to this. Okay, since I know x1, I have here 1 divided by s minus 1 multiplied by u hat divided by s plus 1. So what about the last one? Y hat is equal to it equal to 2 times this plus 1 times this. And this is equal to 2s minus 1 divided by s plus 1 times s minus 1 u hat. As a consequence, this corresponds to the transfer function, and I can simplify like this: 2s minus 1 divided by s squared minus 1 u hat y hat, and this is the transfer function h of s.